Morning.
Morning, guys.
Good morning.
Oh, it looks lovely in this light. Sorry, guys, running late today.
We got a couple people in the.
I think there was actually quite a bit of people because I was sitting like for a few minutes and then and it's just there's already a lot of people. I'm like, it just started.
I guess I opened it first, so I ended up the host. So I'm throwing it back to you, Kim.
But too late. You already got the recording.
Oh, does it?
Uh-huh.
Or does
I learned that if I get on too early, then my machine is locked up for an hour. It's like no. It's held hostage.
Well, Kim, I turned you back into the host. Thank you. Yeah, I might have to, we might have to share a folder or file because I try to post them. Sorry about that, you guys. Oh, no, I'm sorry. I signed on a little soon.
It sounded like someone's phone was ringing.
Here she is speaking. Amazing how that works.
So while we're waiting for people to set up, you want to just open your VS Code so that you're ready when we start.
Okay.
Okay, just send an email out. Oops. Just give it one more minute.
I have lost my view. There it is. Good, got a good turnout.
Yep, we're still missing some.
I know, but we have a good turnout.
Yes,
All right, so can I start sharing my screen? Yeah.
you can.
Can you turn on screen sharing?
Yes.
All right. So I'm in VS Code here, and this should be roughly what you see here, okay? And I'm gonna just make sure that your simulator works, it's all set up properly. You're gonna right click on this robot simulator.java file at the bottom left here and click run.
Okay, Cole, hang on just a second. Let me see. I gotta get us.
Everything's slow.
Yep. And I'm just having you do this first because it does take a little bit to start up on the school machines.
Quick question. How do I get to this?
Did you open VS Code?
I have no clue what that is.
It's on your.
Yeah, we spent last Tuesday setting up VS Code.
Drake, were you here?
I don't think so.
No, I think that was the day he wasn't.
Okay, so what we're gonna have you do is maybe watch. This is being recorded, and then I posted that video in our class pages, so maybe you can watch what we're doing here, and then go back and you can go back and actually follow through with how to install.
Yep.
Or
And if
you
you
can-
want today, Drake, you can just open like a Word document or a text document and just follow along. Okay?
All right.
Because we're going to be doing some coding today. The idea is I'm going to get you situated with Java, hopefully get you to know your way around a Java file, and maybe even know how to write a few lines of code and what they mean.
Excellent.
I got mine to go forward.
All right, I'm going to assume everyone's simulators are working properly. Again, if not, just follow along and contact me after class so I can get it set up for you.
Okay.
Now, where we will be doing almost all of our coding for the simulator and on the actual robot is in this test.opmode.java file. It's in your SRC dropdown menu.
Okay.
Test.opmode.java. Click on it once, and you should get something that looks a little bit like this come up. Okay.
Okay. It's under
As-
Robot Simulator Java.
This is right here. This is SRC, and then inside of there, test.mode.java. And again, this is exactly the code you will be writing for your robot.
Okay.
Everyone
So
there?
under SRC. All right. Test mode.
Good, good.
It's just hard to flip between
Yeah,
watching the screen and seeing our screen. So
Are you able to have both open at the same time?
I can, but I have the luxury of a spare monitor next to me. So I'm just
yeah,
thinking that
but I have
guys
bad
are-
eyes.
they're just
So I
working on
just full screen.
a laptop. It's going to be tough to keep up. So
All right. So actually, here's what I'll do. I'll just make it a little bit bigger for you. I don't actually know how to do that, so maybe not.
Pull your side thing over to click on the
Oh, there it is.
the edge of it and pull it over.
There we go. Oh, that's a little too much. That should help a little.
it's,
Right.
it's not so much the size of the image. It's that we have to have two screens open and
Yeah.
So-
But having it bigger should help. All right. So this bit of test code that was already in here was just so I knew that your simulator was working when you got it running. What I would like you to do is I would like you to highlight everything from this kind of blank area right here after void run out mode all the way down to right. You should have exactly this copied. If you have any more than this copied or any less than this copied, you'll get an error. And I want you to hit delete.
Gulp.
Okay, we're starting from scratch.
Aha.
Okay,
Wait, how high do I go?
this much.
Hang on, it's little. Okay.
Okay.
So, from here to about. Double check.
The first squirrely bracket
Mhm.
or brace or whatever they're called.
Yes, so that's actually what I want to talk about here. So I'm going to hit delete, and I want to talk about these curly braces here. So you'll notice in this file right here, looking pretty bare, that there are 4 curly braces. One right here, one right here, one right here, and one right here. Okay, and I'd like to tell you what those mean. So do you remember in Python how when we wanted to do make a function, we had to define it like this. Right? Def, then the name of our function, 2 parentheses, and then a colon. And then anything after the colon we had, you don't have to type this. Anything after the colon we had, we said was inside of our definition of something.
Mhm.
Yeah?
Yep.
That makes sense? Java has something very similar, okay? Instead of a colon and then having everything be tabulated inside of that or after that colon to call it inside of the function, we use these curly brackets to make up the body of our function is what we call it. So anything between these 2 curly brackets, we say is inside whatever's before the curly brackets.
Okay.
Okay. And actually what's nice about VS Code is that if I click right here, in that little space between the curly brackets, it highlights or puts a little square around the curly brackets that I'm inside, or the body that I'm inside.
Okay.
If I click right here, it tells me I'm inside those curly brackets. If I click right here, it tells me I'm inside these curly brackets. So whenever I tell you to put something inside of something else, I'm referring to putting it inside of the curly brackets after the name of the thing I tell you to put it inside of. So if I told you to put code inside of run op mode, I would be telling you to put it right here, which is between the curly brackets. Okay. It's important to know because I'll be throwing around language like that all the time, telling you to put functions inside of other things and all sorts of stuff. But specifically, almost all of the code. Yeah.
What is the technical name for what I called the curly braces? What?
Yes, they are curly braces, but when you have two of them like this, we call it a body.
Okay.
Being
And
attacked by a cat.
yeah, there is actually a proper term for these curly braces, and I think it's actually funnier than the than curly braces, the name. I do not remember what it is though. Maybe someone look into that. But almost all of the code we'll be doing, all of the code we'll be writing for our robot will go inside of run op mode. Remember, I said inside of, it means between these curly braces. So if I wrote code here, it will run when we run the simulator.
Okay.
So let's do that. Let's print something out to the screen. Now, when I had run the simulator before, and I'll leave this window open so we can see it, there was a little window, green window in the top left corner. And there's not anything in the window right now, but this window is what we call the telemetry window on our robot. And it's where we can print out text. So I can print out words up here. I can print out numbers. I can print out variables up here. It's extremely useful. And it's what we'll be using on the robot, the actual robot, to know what's happening while it's driving around the field. So to use telemetry, the robot has a built-in variable or a built-in function called telemetry, and I'll have you type this in. Telemetry. And in Java, whenever you want to tell something to do something, whenever you want to tell a variable to do something, we have to put a dot after it. And when we put a dot after telemetry, it brings us this nice drop-down menu of all the different things that telemetry can do. Okay. Just making sure everyone's getting there.
Now mine isn't indented like yours, Cole.
What?
When I type telemetry, it didn't indent. Is indentation significant?
Indentation is not significant, but you will never find code that doesn't have it.
Okay.
So it is extremely useful to do.
It's just good for readability. Okay, I just didn't know if it was all right.
Jomar, you said you need help finding these files? Do you have your VS Code open?
No.
Can you open VS Code?
Yeah. Gotta download it.
You have VS Code open? Oh, you need to download it. Now, were you here on Tuesday?
Yes, I think he was.
Yeah, I was here when we started setting up the fusion and stuff.
So were you not here on Tuesday then when we set up VS Code?
Yeah, I don't think I was.
All right. Well, can you follow along in like a Word document or something for now then and meet me
Yeah.
after class and I can help you set it up?
Also, the video is posted, so he can
Yes.
follow that as well.
All right. Let's continue. When I put this dot after telemetry and this drop-down menu appeared, I would like you to click on add data because this is the one that's going to be important for us to write something into that little green telemetry window. If you click on it, you'll see it kind of adds some code after telemetry.
Mhm.
And this is a function, exactly like what we did in Vex. Remember in Vex how we had 2 arguments inside of our parentheses, right? We had we had to tell it which direction we wanted it to go. We had to tell it how far we wanted it to go. So this is exactly like our Vex robot, except that here it's a little different in that instead of telling a robot how far to drive, we're telling telemetry what to put in that little green window.
Okay.
Now, these two arguments, remember arguments are these comma separated things in the parentheses. These arguments are expected to be something called strings, which is, they're just sentences. So it expects these 2 things to be sentences. So let's add some sentences in here. If you double click on this and replace it with double quotes, double click on your caption, replace it with double quotes, and let's make it say hello world on the screen. How about that?
That's unique.
Hello. And then for the second one here, the second argument that's coming, I'm gonna put world. See all my errors go away.
The first one is just hello, right?
Yes.
Oh, and then the second one is in quotes again too. Okay.
Yes. So this is called a string in programming, and in all programming languages, it is called a string. A string is kind of a series of letters strung together to make a sentence or a word or something. And they're very useful for language when you want something to be readable by a user or by a person, because a computer doesn't necessarily understand what letters and words mean. All right, everyone have that typed in? Once you have that typed in, let's see if it worked. Let's right click on our robot simulator.java and click run. And then remember we have to hit play. And I don't see anything show up in the window. And that's because for this telemetry, we have to tell it to take what we added. So we have to remember, we just called telemetry.add data and then with our words. But we still have to tell telemetry to put it out onto the window. We have to tell it, send it to the window. We have to tell it to update what's on the screen. And luckily, telemetry has a nice built-in way of doing that. So we'll go back to our test.mode.java code. Okay. And I want you to go to the end of that line after the little semicolon that got put in here. Hit enter so that it creates a new line, and you'll notice it automatically indented properly. We're going to type in telemetry again because we want telemetry to do something else this time. This time we want it to update our little telemetry window. And again, when we want a telemetry to do something, we put a dot after it, and our little list of things that it can do shows up. And this time I want to update, and that's this one right here. Okay, so click on update, and your errors go away.
Okay, update. Oh,
Right. When you think you've got that all typed in, right click on robotsimulator.java and let's run it again. Look at that. Look in our little window up here in the top left.
but you said you also have to hit play or just run.
Run, you have to run it.
Okay, I did, but I'm not seeing it in my, oh, there I see it. Okay.
Look in our little green window in the top left. I see hello world. And notice how there's a little colon that appeared between our hello and world. And that little colon shows up because of how we wrote our add data. The add data function for telemetry adds a colon between the first and second arguments. It's very useful to know. Okay. Let's try something else. Another useful thing to note is that when I ran this code, and I'll show this again here, hello world showed up immediately, right? I didn't even hit the play button. It's already there. So what if we wanted to wait for the player to hit play before the robot does something, right? Because if I hit play, it's not going to change what's on screen. Let's do that. So I'm going to make it so that when I hit the button, when I hit the play button, it'll print something different out onto the screen. So again, I'm going to go after telemetry.update, hit enter. I'm going to hit enter twice so we have a little bit of space. Okay. And I'm going to use another built-in for the robot. This built-in thing waits for the user to press the start button. And that's wait for start. Okay. This is a function, which means that there are parentheses after it. And again, unlike Python, in which this would be an off code to call wait for start, Java requires that you have to put a semicolon after your line. So after you call a function, you have to put a semicolon, always.
Mine inserted the semicolon automatically, it seems.
Yes. So if you click on the little drop down, it'll automatically put that semicolon in for you, which is nice. But this line of code waits for the user to press the start button. Any code after this function happens after you press start. So let's add some code after that. So I'm going to go down 2, and I'm going to make telemetry print something else. Okay. So to make it print something else, I could type out all of this stuff all over again, or I could just copy these 2 lines with my mouse, Control C or right click copy, go down here below wait for start, and Control V or right click paste.
Okay.
Okay. And let's make it print something else out this time, because we want to know that this code executed after we hit play. So I'm going to make it say something different. I'm alive.
Better not be.
Yeah, uh-oh.
I'd take a hammer and go boom, boom, boom. Boom,
That
boom.
don't look like schoolwork.
All right, let's run our code. So
Assure them it's schoolwork.
let's see. So we have hello world in the top left here, which is what we expect, right? Because we haven't hit play yet. But when we hit play, we should see I'm alive. So let's try it. Oh, look at that. I'm alive.
I mean, I would assume so.
Yeah.
Cool.
I just realized that's a simulation of, I think this competition's challenge.
Yep. So congrats, we know how to write code now that will print things out to telemetry, and that's incredibly useful. You'll see later on when we're debugging things. So what do you say we try and make the robot move a little bit, okay? In order to make the robot know how to move, I have to introduce something called the hardware map. And I've prepared 2 slides, a whole 2 slides in a PowerPoint, just to quickly illustrate what that is, okay? So on our expansion hub, which is this little black box right here, this is the kind of controller for everything on our robot. It's kind of like the Vex brain. And this has motor ports on it. It has servo ports on it. It has all sorts of things on it. And this is what we'll be telling our motors how they should spin and what motors should spin. And I know this picture isn't great. We'll see if I can zoom in. Oh, that's not right. Yeah, no, it doesn't want to let me zoom. But there are 4 motor ports along the left here. Each motor port can be connected to 1 motor each. And each port has a number associated with it that we call the channel, the motor channel. And normally this would be enough in our code, to tell us how to control our motors, right? We could just say set motor channel this to this power, and the motor would spin. But FTC does it a little bit funky. They have a hardware map file, and you'll see this on the actual robot too. And in the hardware map file, a name or a string, remember, that's the thing in quotes, is assigned to each channel. And in the code, you can control a channel by calling its name. By, you can kind of address each channel by its name.
Mhm.
Okay. And if you want to find what your hardware map is, you can go into hardwareconfiguration.json, which is a file in your simulator. It's right above, I believe, test op mode. And you can look in there and you should see exactly what I have screenshot here. And that tells us that channel 0 is connected to our left drive motor, channel 1 is connected to our right drive motor, and channel 2 is connected to our middle drive motor. And that's exactly how I have this simulated robot wired. I have channel 0 on the left side, channel 1 on the right side, and channel 2 in the middle because we chose H drive, right? So let's go back to our code. And now that we know what our channels are, or what we know what our hardware map is, we can control motors. So Connor just asked a question in the chat here. Okay, so I had sent Connor an updated version of the simulator, like pre-release. You guys can see it. That would be in the configurations folder.
Thank you.
So to control a motor, we have to create a motor variable, which is something a little bit weird to think about. Normally, when we were creating variables in Python and in Vex, we would do something like this. We would call it, let's make a variable called pickle. And we would just set it equal to a number, right? That looks normal, except that that doesn't work in Java. In Java, you see it says it cannot be resolved to a variable. In Java, you have to tell a variable what kind of variable it is or what kind of information is inside of it. For a variable that is going to hold numbers, we use a type int. And the type that you want the variable to be, or the kind of information you want the variable to hold, is told right in front of the name. Right? So by saying that pickle is an int or an integer, as int is short for, we say that it can only hold whole numbers. So if I tried to put in like 5.5, it would tell me that you can't do that. So that's an important point to remember. Variables in Java have to have a type. That being said, they do not have to be normal types. For instance, an integer is kind of a normal type. It is just a number. It's pretty simple. But we can also have a type that's something like a motor, for instance. And that's exactly how FTC does it. They have this DC motor type. Oh, that's an amazing spelling. They have this DC motor type, and you see it shows up this kind of pale green color, exactly the same as int. And we can give it a name right after it, just like we did with our pickle variable. And I'm just going to call it motor to be simple. And again, just like our pickle variable, we set it equal to something. But what do you set a variable of type DC motor equal to?
It's channel maybe.
Yeah, we have to get that motor from a channel. And to do that, there is another thing like telemetry that is built into our robot, and that's called our hardware map. See, there it is. And remember, our hardware map kind of contains the connections between our channels and our names. So I tell hardware map to get something by typing dot. It tells me all of the things hardware map can do. And we're going to be using this get command. I'm going to click on that. Oh, got another
Cool.
chat.
This is very cool.
Oh, I clicked on the link. Whoops. No. Okay.
Cole, which of the gets do we click? Does it say get
Back
class
here.
or
Actually, you know what? Here's what we'll do. I'll just type it out. So hardware map.get parentheses. The first argument here, you don't have to worry about. I'll just tell you what it is, but if you're interested, I can tell you what it means later. You're going to put in DC motor.class. That's the first argument for get. The second argument is the name that we associated with the channel that we want to get. So I'm going to say, I'm going to look in my hardware configuration.java or JSON. I'm going to get our left drive, which is connected to our 0 channel. And that's left_drive. And that goes in quotation marks because it was a string.
Mhm.
Can you hang on just 1 second?
Sure.
So I see DC motor, but I shouldn't have clicked on one of those. You're like actually hand typing it.
Yes, I hand typed it.
Okay.
Yes, and I said, do not worry about this first part here. You shouldn't have to change that.
Okay. And then, all right, I think I'm caught up. Sorry.
No
Okay.
problem. And then I want you to put a semicolon at the end of the line because remember, Java requires that you put a semicolon after every function.
Okay.
All right, good. So now our motor variable has inside of it a way for us to control motors and specifically control our left_drive motor, just in the same way that our pickle variable holds a 5 inside of it.
Always
So I'm going to
important.
go after that line we just typed, hit enter. So we have a little bit of space and a new line to type on.
You always have to have a space in between each of those.
You don't, but I think it helps for visualization. It does not change how the code will execute.
Okay.
And let's make our motor do something. Remember, when we want something like a variable to do something in Java, we type it in and we put a dot after it. And that tells us all of the things that it can do. And you'll notice there's quite a few more things that a motor can do than some of the other things we saw. You can actually scroll up and down in it. There's so many things. But for right now, we want to just set the power to it so that it spins. And we can use this set power command or function right here. And this is the one that you'll be using most often. You really don't need to worry about the other ones right now. Mainly because I haven't fully programmed all of them. So we'll click on that. And it brings up our parentheses again.
Oh, get power, not set power. Okay.
Oh, sorry, set power. That's what I meant. I lied. There we go. Set power. And set power takes one argument inside of its parentheses. And that's how much power you want to set to left drive. Or how much power you want to set to your motor.
Now, Cole, on mine, it doesn't say double power. Mine just says power when I called up the set power.
Right. Is that because you clicked on it?
I believe so, yes.
Yeah. So if you click on it, that would happen.
Okay.
But motor.setPower takes one argument, power, And that power must be between -1 and 1, where -1 is full speed backwards and a +1 is full speed forwards.
Okay.
0 is not spinning at all.
Okay.
So I'm going to set our power to 1 because I want it to go full speed. And I'm going to put a semicolon at the end of the line.
Okay.
Let's run our code and see what it does. We have quite a bit here. All right, we have hello world in our little telemetry window up here. And when I hit play, what do we expect to happen? Remember, I'm setting our left drive motor, which I've wired to our left side of our robot. Should expect the robot to spin in circles. So let's
Gonna spin a circle clockwise.
Yeah, let's start. Ta-da!
Very cool.
Congrats, we've made the robot move. Let's see what else we could do. So I have a challenge for you. And I'm not sure if I should leave this until next class, but I want you to set the right motor to also have 1 power. Okay. And I also just want to demonstrate, remember it's spinning clockwise here. I can also set the motor power to a -1. Remember, that was full speed backwards. And it should spin the other way. Oh, that was the wrong play button. I hit play. There we go.
That's funky.
And just one more thing, I want to demonstrate that you can have kind of fractions or decimals of power. So if I wanted to set it, remember the maximum was, +1 to -1. If I wanted to set it to 0.5 or 0.5, I can do that. And we should see it go at half of its speed because 0.5 is half of its maximum speed. So let's run that. Let's run it. Yeah, and it goes much, much slower. All right, so congrats. I think we're at the end of our class time. But you know how to make your robot spin in circles now. So that's a big accomplishment.
That's awesome. Do you have a suggestion as to what you want them to try to do for next
Yes,
class?
I would like you to try and make your robot do a few different things. Or one of a few different things. Either I want you to make your robot drive in a straight line until it hits the top of the screen. Or I want you to make the robot do a 0-point turn in place. Okay?
Great. Guys, this will be a grade. So right now, if you have a second and you were not able to keep up, do a screenshot. Again, you can use your snipping tool to screenshot it and go to your search bar there, type in snipping, you'll get it new, select the area, and then paste it into a Word file. Or you can also, if you look at the top of your screen, you should have a print screen. So that does the same thing and then paste it into Word. So, or you just need to be able to see this. This video will be posted as well.
All
Very
right.
cool.
Congrats. That was a good, one.
That was really super awesome. Guys, what do you say?
Thank you.
Thank you.
Thank you.
Really cool. Yay.
Thanks.
Thank you for being polite, everyone.
Bye-bye.
Bye-bye.
See ya. If you hear
Bye.
that, that's my brother playing something at high volume. All right, bye.
Bye-bye.
Seth, you still there?
Seth, where are you, Seth?
Hi.
You know what? I must have had my
Seth, did you
non-video.
get that? Oh, go ahead.
That was pretty good.
Seth, were you able to keep up?
Yeah.
Okay, perfect. You're all set. So just do what Cole asked you to do for next lesson, okay?
Okay.
And again, this is going to be posted. So if you need to see it again, it's going to be posted.
Okay.
All right. See you later.
See ya.
Bye-bye.
Bye.
Okay.
Nice job. That helped. I had the lesson yesterday, so I did much better today keeping up.
No, that was really good. Really good.
When you made a robot spin in a circle, it's not incredibly impressive looking.
No, but it's a beginning for these kids to realize they can do this. This is
Of course,
really
I'm thinking about how to do a zero. What
A
was it?
0-point turn.
0-point turn.
Can you
So-
assign just one wheel, or do you have to have your two motors going opposite directions?
The motors have to go in the opposite direction.
So if you set one of them to a 2, the other one would have to be a -2,
Mhm. But I
or
can
a
only-
0.5 and a -0.5.
Yeah.
look at you.
Yes.
Star student. Awesome. You
Um,
guys, that was really awesome. It was great. And the pace is really good too, because again, I'm working on a small computer like the students are, and I'm trying to go back and forth. So you're really like excellent in patience.
Yeah, I don't know if I'm going way too fast or way too slow.
No,
I didn't have any problem telling you when I couldn't keep up.
yeah.
You're going at like perfect speed. It's just my internet loves to be at least 2 minutes behind you, and it's
That's right. We have to operate at 0.5.
Cheryl, I think you do have control over the recording. You can
I
probably.
So do you want me to, my computer's always weird when I try and share files if I'm not at school.
Okay.
Do you want me to, I can like throw it into my YouTube and share it with you that way?
Yeah, that's fine. I'll just download it and then put it in. And I can even actually just link it. So if that's okay with you.
You know, that's
Oh.
fine, but I can give you the actual link to it.
Okay.
I'll
So
just,
cool.
I'll do that. I'll throw it into YouTube.
Okay.
Cole, I have a string joke for you to share with the class next time.
Yeah.
Okay, so 2 strings walk into a bar and
It's probably gonna be like a builds character joke or something.
goes up to the bartender and says, bartender, well, I want a drink. The bartender looks over the counter and he says, we don't serve strings here.
Oh yeah, I've seen this.
So the two strings go, the one says, come on, let's get out of here. Let's go. He says, I'm not leaving anywhere. He says, hold on, tell you what, free my ends and tie me in a bow. So he does. And so he waddles back over to the bartender, says, bartender, I want a drink. He says, I told you we don't serve drinks here. He says, I'm afraid not.
I'm sure you could come up with one where it's like about string concatenation and how it builds character. But
Work on that one. We tie them end to end. If I could teach the world to sing in perfect harmony.
I used to love that song.
Yep, that was good.
I have a question.
Yeah.
Miss Dry and Dr. Higgs, in your email, there should be something from Fusion, I believe. And it should be like an invite link or something.
Okay. Right now? Or
Is this something that was sent or just sent now?
I just sent like at the beginning of class.
Okay.
I don't have anything yet.
Huh?
Oh, wait. No, I do not.
I got a remote Steam. Not yet.
Yeah, it might be a second.
What should I do with it when it comes?
I forgot how it looks, but it's basically me and Cole created a Fusion team, and we both put projects on there for Fusion's class and whatnot.
Oh, wow.
And so Cole laid out a page for the entire robotics class, and everybody has their own folder and whatnot.
You guys are the bomb.
okay, let me open that real quick.
That is awesome.
I'll share my screen here and just show it.
Yeah, I just went through and emailed everybody, so I just wanted to see if they would come through, if they see it.
I have something from Fusion from a couple days ago. Do you want me to, do you want to see what I have?
Sure.
Oh, my screen is
Is it
lagging.
this?
Oh, I'm crashing Zoom.
Yeah, that's exactly it.
How am I crashing
I got
Zoom?
this on the 20th. Oh, I got this on March 21st, 2020.
We're way ahead of us.
Oh, this must be, so Cole, when you and I were first looking at Fusion, was this the account we had set up?
No, it's kind of like a subfolder. I mean, yes, they won't be able to see that account really or edit it. But I've given each of them a folder here. And I think
Yeah.
Connor sent out the request to each of them. Yep.
Yeah. Can you
and-
see those?
Oh, I have to approve them personally, don't I?
Oh, yeah, dang.
Okay, I can do that.
I love how some people's name are capitalized, but some aren't.
Huh.
Don't click too fast on the reject button.
I hope I don't reject anyone. All right, look at all these people. And then we'll have to ask them to not modify someone else's folder. Unfortunately, they're going to have to just kind of be on an honesty policy here.
Uh-oh.
There might be a way.
Connor.
What? You just got?
Yeah.
Okay, so then Cole had to go through and approve everybody.
Yeah, because I believe I'm the host for this.
I got something from Connor saying, welcome to the project robotics class, right?
Yeah.
Yeah. And now in theory, if you open up Fusion, you should see a team thing.
Hang on. Let me get out of full screen mode.
Oh shoot, I'm still sharing, aren't I? Connor, I think we need to I need to redesign those little brackets for the wheels for the swerve drive to the bearing.
Yeah.
Yeah, the screw head is too large.
Screw.